All right, in this video we look at more examples on parallel, perpendicular and oblique straight lines. In this example we're going to find the equation of a straight line parallel to the given line passing through the specified point in part 1. In part 2 we're going to be looking for a line perpendicular to the given line going through that specified point. So let's see how A works out. So in A we have so the given line is to y is equal to 2x plus 1. The specified point is negative 2, 5. Okay, so the given line we are going to take as our L1. So the equation is already in standard form. So from that equation we can see that M is 2 and C is 1. And so from that we're going to make a quick sketch of what this line is going to look like. So since C is 1, this line is going to go through the vertical axis above the origin, and since M is positive, it's upsloping, so M1 is to there. Then negative 2, 5 is going to be somewhere in the second quadrant. Okay, so the line in part 1 that we're looking for is parallel to this line, and it goes through negative 2, 5. So this one we're going to call L2. Then in part 2 we're going to look for a line going through that same point but making a 90-degree intersection angle with the given line. So this one we're going to call L3. So for the parallel line, that one is going to have the same gradient as our given line. So M2 is going to be 2 as well. Now since it goes minus 2, 5, we are going to use the 1-point form of the equation of a straight line. Y1 is 5, M is 2, X1 is negative 2, so that becomes X plus 2. Then removing the brackets this side, this is going to be 2x plus 4, and so this thing is going to be y minus 2x minus 9 is equal to 0. So that is going to be the equation of the line parallel to y is 2x plus 1 going through negative 2, 5. Next we're going to look at the equation of the line perpendicular to L1. So this time perpendicular. Now if L1 and L3 are perpendicular, then M1 times M3 is going to give us negative 1. So we are going to have 2, which is M1, times m3 is equal to -1. From this, it's telling us that m3 is -1 over 2. And since the line goes through this same point, -2, 5, then our equation is going to be y minus 5, -1/2 x plus 2. Notice this is exactly the same as this equation here. The only difference is the gradient now is going to be the negative reciprocal of that. And then again here, we are going to multiply everything by 2 so that we don't have to deal with fractions. So this thing is going to be 2y minus 10 is -x minus 5. So we're going to have 2y plus x equal to 5 if we bring the other term to the other side. So it's just a small typo here. This is 2. So 2 minus 2. So this is going to be equal to 8. So this is going to be the equation of the line perpendicular to L1. Okay, then we're now going to go to example number B. In B, we have got 3x plus y is equal to 7. We're looking for a line which goes through -3, -5. Now this line, which we're going to call our L1, the equation is not in standard form. So making y the subject of the formula, we've got y equals to 7 minus 3x, from which we see that the gradient of this line is -3, the y-intercept. So again, if the gradient is negative, the line is downsloping. The y-intercept c is 7. So we're going to do a sketch of this line. So this line crosses the y-axis at 7, but it is downsloping. So 0, 7, and the line is downsloping. M is -3. Then the point of interest is -3, -5. It's in the third quadrant, so we're going to be interested in a line parallel to M1. So that means this one is going to have the same gradient as this one. And then the other line needs to be perpendicular. So M3 we are going to calculate. Alright, so we're going to start with the parallel line. So parallel. So here we're going to have y minus -5, and on the right hand side we're going to have -3 into x minus -3. So minus negative, of course, is plus. So we have y minus -5, so it becomes plus. This is going to be x minus -3, it becomes plus. So we're going to have y plus 5 is -3x minus 9. So that's going to be -9 there. Bring everything to the same side. So this is going to be plus 14 is equal to 0. So that is going to be the equation of the parallel line. Then now when you go to the perpendicular, okay, then if we call M3 the gradient of the perpendicular line, then this times M3 must give us -1. So M3 is going to be 1/3. In short, the gradient of the perpendicular line is always the negative reciprocal of this one. So if we go from here to here, it's a negative reciprocal. So you flip this over and multiply it by -1. So again, it's going to be the same equation as this one, but this is going to be 1/3. So we're going to have 1y plus 5 is equals to 1/3 into x plus 3. And then again, the 3 we bring this side to the left hand side, and then after that we bring everything to one side. So this is going to be plus 12. Right, I think we're going to do one more before we give you two to try. In C, we have 8x minus 6y is equal to 5. We are looking for a line that goes through 7, 0. This equation is not in standard form. So if we convert it to standard form, we're going to have y is equal to 4/3 x minus 5/6, which means m1 is 4/3. If m1 is 4/3, which is positive, means this line is like a forward slash. C is negative 5/6. So that means this line is going to be crossing the y-axis below the origin, and then it's going to be going up like that. M1 is 4/3. Okay, this is y, this is x there. Then 7, 0 is going to be a point there, which means the parallel line is going to go something like this. Parallel line is also going to have the same gradient, 4/3, and then the perpendicular line is going to go something like that. So its gradient is going to be M3. That must be 90 degrees. All right, so the equation of the parallel line is going to be y minus y1, this is the 0.70, y1 is 0, and then 4/3 x minus 7. So if I bring the 3 to this side, then this is what we're going to have. So 3y is 4x minus 28. So if I bring this everything to the same side, this is going to be the general form of our equation. Then for the perpendicular line, so for the perpendicular line, the equation, the gradient is going to be the negative reciprocal of 4 over 3. So we flip 4 over 3 becomes 3 over 4. We'll multiply by negative 1. And then the equation is going to be exactly the same. So negative 3 over 4 now x minus 7, which is similar to that one. So this time bring 4 to the left hand side, x minus 7 here. So this is going to be 4y is equals to negative 3x plus 21 this time. So the final equation is going to be 4y plus 3x is equal to 21. All right, at this point, we're going to give you an opportunity to have a go at these last two. So just have a go at D and E. Just pause the video, and then when you press continue, then you can compare with our answers. All right, we're now hoping you've had a go at D and E. I'm going to scroll down to our solution. So in D, we have got y equal to 8 minus 4x. We're looking for a parallel line through 3, negative 4. So this is already in standard form, from which this is going to be our gradient. So since it's negative, it means the line is downsloping. This is going to be our y-intercept. So that is going to be 0, 8 there. So our line is downsloping. So that's going to be the orientation of it. Then 3, negative 4 is in quadrant number 4. So looking for a parallel line. So that means this line is going to be the same gradient as this one. So M2 is also going to be negative 4. And so for the parallel line, we're going to have y minus y1. So it's going to be y minus negative 4, which is the same as y plus 4. Then negative 4, this one is the gradient. Then we're going to have x minus 3. Removing the brackets, this side is going to be minus 4x plus 12. Then we can bring the 4x this side, take the 4 to the other side, we've got y plus 4x is equals to 8. So that is our equation. Then for the perpendicular line, its gradient is going to be the negative reciprocal of this. So if we do the reciprocal first, and then we'll multiply this by negative 1, then we just have 1 over 4. And then we're going to do the same equation as this one. This is now going to be 1 over 4, like we do here. And then if we multiply through by the 4 to clear the fractions, so the final equation becomes 4y minus x plus 13 equal to 0. It doesn't look very much correct. This should be plus 19. Okay, then for E, the equation is 4y minus 2x is negative 5. If we put this in standard form, comes y equals half x minus 5 on 4. So M1 is 1/2, which is positive, so we've got a line that's upsloping. C1 is negative 5 on 4. So the line is going to go through negative 5 on 4. It's going to be upsloping. So like a forward slash. Then negative 7, 3 is in quadrant number 2. So looking for line parallel to this one, going through negative 7, 3. So if this is gradient half, that's also going to be gradient 1/2. So then we can plug it here. We've got y minus y1 is 3. Gradient is 1/2. X minus negative 7 is x plus 7. Bring the 2 to this side. We're going to have 2y minus 6 is x plus 7. And then bring the x this side. Got 2y minus x is equal to 13. Then for the perpendicular line, first we do the reciprocal of half, which is 2. Then we put a negative, so it's going to be negative 2. Then we plug into an equation similar to this one, but for the perpendicular line, the gradient is negative 2. And so we open brackets here. It's going to be minus 2x minus 14. Then if we bring this to this side, then we've got y plus 2x plus 11 equal to 0. Alright, thanks for watching. I think we're going to stop this video here. So we're going to have a part 4 of this series of videos. Hopefully this has been useful. Please do subscribe so that you can get notified whenever we post new material. Thank you.